Okay, so I want to start the chapter 6 stuff today, and it's very related to chapters 4 and 5 because we are going to start talking about simple harmonic motion. What is a simple harmonic motion? So a motion that repeats itself in equal intervals of time is called a simple harmonic motion. Shall we write this down? A motion that repeats itself in equal interval of time is called simple harmonic motion. A simple harmonic motion is defined by or can be described with a second order differential equation. So for a mass spring system, which is basically a mass connected with a spring, either resting on a table moving back and forth, or it could be hanging, moving up and down, either way. But for this particular scenario, when it is resting on the table, moving back and forth, if we ignore friction and drag and all of the other things, this motion is described by the equation given by a second order differential equation of this form. Since this is a motion that's repeating itself, and when we talked about the simple pendulum, if I was to project a simple pendulum onto the floor, what does this motion do? It goes this way, then goes that way, comes back, projects forward, comes back and forth, right? Is this the same motion as we talked about when we had a circle moving around in a circle? When we had a mass attached to a spring and we were twirling it around? Yes? Is this the same kind of motion if we project it down? So all of these kinds of motions that repeat themselves in equal intervals of time can be described by sort of the same second order differential equation. And the fun part is the form will change because this part will change, right? Depending on if you have a pendulum or depending on if you have a mass attached to a spring. But they are all described. So may I erase this? Because we will talk about them later. And the solution to this will always be of the form x as a function of time equals a cosine of omega t plus b sine of omega t. People in math physics, can I also write them as e to the I theta plus e to the minus I theta? Is that sines and cosines? Do you guys remember the hierarchy? The same thing. So Euler's equation is also e to the I theta, which was what? Cosine theta plus I sine theta divided by 2? No, not divided by 2. And then if I have a minus sign here, what will this become? Minus here. So this can also be written in the form a e to the I theta plus b e to the minus I theta. which basically results to cosine of omega t plus sine of omega t. Okay. Where omega is what? Angular velocity or angular frequency given by 2 pi f. Which can also be given for this particular scenario as k over m square root. For a mass spring system, omega is given by k over m, where k is the spring constant and m is the mass on the spring. In 99% of these cases, we will ignore the mass of the spring.